Network intrusion detection system. The system comprises of two major primary parts, the detect 7B and drop 54. The detect 7B tries to match for 56-bit patterns in the data that is incoming, and the drop 54 contains a dual port memory. It stores the data packet in the memory and drops if the detect 7B has found the pattern that we are looking for. And the detect 7B is further comprised of H9B, bus merge, and word match. Word match comprises of comparator, while drop 54 contains a dual port memory and H9B. Each of these modules and their functions will be explained further in this presentation. The comparator is a 56-bit comparator, so it consists of a 8-bit comparators, and each of the outputs is odd with a mask. So the purpose of this mask is to block out the parts of the pattern that we wouldn't care for matching. For example, in some instances, as illustrated in the next, illustrated in this slide, if we want the entire 56-bit pattern to match as shown in the first case, that is the dead beef pattern, then we just leave the all A mask bits as one. But say we don't care about some bytes of the pattern, and we are looking for 1 byte or 2 bytes present in the periodic locations. So in that case, as shown in the second case, if the A mask was not present, or if A mask is set to all ones, it doesn't find a match despite there being a match of the pattern that we want. To avoid this, we just use the A mask and then set the values for the bytes that we don't care for matching to 0, as illustrated in the third case. The Reg 9B is actually a 72-bit register that contains that comprises of flip-flops with clock, clear, and enable. The bus merge just takes in two inputs of 64-bit and 48-bit and gives out a 112-bit output by concatenating the two. Word match. Word match comprises of 8 of the comparators that we discussed earlier, and each of them get the same A mask. But the inputs to each comparator are just byte shifted. So as you can see here, all these comparisons happen. The data in the dark blue pattern is the input data, and the light blue one is the pattern. So each of the 8 comparators in the word match look for the match in the patterns for one of these. So in total we have 8 over here. So in a single cycle we are able to find a match for any of the pattern present in any order. So this is the primary detect 7B module that contains a couple of flip-flops, and then a word merge, bus merge, and reg 9. As you can see, the hardware reg is a 64-bit register that contains the pattern that we would like to look for and also the mask value, and that goes into the word match. And as illustrated by pipe 0 and pipe 1 mechanism, we are trying to look for the patterns that start in one 72-bit packet but also carry forward into the second one. So in bus merge, we see that we are going to use lower 63 bits of the current data and the upper 48 bits of the previous data. So this way we can ensure that we find the pattern if it has carried forward from one packet to the next. And this is a drop FIFO. As you can see, this is a simple FIFO with dual port memory at the end, and it is enabled with a match signal as illustrated here. The drop packet is the signal that comes from the detect 7B that gives a match, and when there is a match, we assert the drop packet signal, and that enables this FIFO to drop the packet. So the circuits were made in Vivado ISC, and with the test benches provided, they were simulated. So if I go forward and simulate this, as we can see, there is some input data and there is some output data. On further inspection, we do note that on further inspection of the input data, we see that the data is a consecutive packets of 0, 0, 0, 1, 0, 2. But however, when we go in the packets and inspect them manually to find a pattern that we are interested in, we see that there is a pattern in this after 3A and 3F. So once we go to the output data and then check for the data in there, we notice that after the yes, we notice here that after 30, the entire packet that contains the pattern of 07 was dropped. So this was our primary function of our intrusion detection system. So this illustrates that it works as intended. Thank you.